All right, this is our lecture um, 5.4, graphing square root functions. This is going to bring back memories of some material from last semester. I understand the parent functions of square root of x and cube root of x, and I can graph transformed square root and cubed root functions and identify both the domain and the range of these functions. Domain is our x values and range is our y values. X are inputs, range are y, which are our outputs. So if you recall the parent function of a square root function, let's back up. The square root function is one of the radical functions. Radical, that is that symbol right there. And so we have the square root of x. That is our parent function right here. Okay, so this should look familiar to you. This is, it starts at the point 0, 0, and it moves upwards to the right. And when we had this in the past, we would take and say, okay, this is our output. What is our y, which is f of x, and it equals the square root of x. And so if I had 0, the square root of 0 is 0. If I had 1, the square root of 1 is 1. If I had 4, the square root of 4 is 2, and so forth and so forth. Now, we have learned recently that we cannot have a negative number underneath an even radical, right? Because we can't remember the radical ask in this case, let's say the square root of 16, what times itself twice is equal to 16? And if it was a negative 16, there are no two numbers that can multiply by times each other to get negative 16. Okay, so two identical numbers, that is. So at any rate, there is a domain restriction. If I have an even radical, my x values have to be greater than or equal to 0. And so if I wrote it in set notation, I go from 0 to positive infinity. Range are my y values, and if you look at the graph, you'll notice that sure enough, there's a restriction on my range that my output is going to be greater than or equal to 0. My intercepts are 0, 0. There is no symmetry. This function is not defined when x is less than 0. In behavior, as x goes to positive infinity, y goes to positive infinity. Okay, so this is our parent function of a square root. Now, again, recall that we have some domain constraints that we have learned about. There's more to come, it would appear. Okay, x values, we have constraints. We cannot divide something by 0 because that is undefined, and an expression inside an even radical cannot be it has to be a non-negative. It has to be 0 or bigger. So let's do a couple problems to refresh our memory on how to find that. Identify the domain for the following functions. In A, we have an even radical. This is the square root. And so we know that 2x minus 8 has to be greater than or equal to 0. If it was equal to 0, square root of 0 is 0. So that's fine, but it has to be greater than or equal to 0. So we can solve such that we find 2x is greater than or equal to 8, and we find x has to be greater than or equal to 4. So this is the domain constraint. X has to be greater than or equal to 4. Now in B, we are looking at, we have two situations. One, we have a radical, and it's an even radical, so we know that x minus 9 has to be greater than or equal to 0. Well, if it was equal to 0, I would then be dividing by 0 because I have the square root of 0 is 0. So in this situation, we're just going to jump to the fact that that underneath the radical has to be greater than equal to 0. I'm sorry, greater than 0. And so x has to be greater than 9. Okay, because I can't divide by a 0 and the value underneath the radical has to be greater than 0. Okay, why don't you try one yourself? Welcome back. I have an even radical, so that's a square root. I have 8 minus x has to be greater than or equal to 0. This radical is not in the denominator, so I don't have to worry about what we did in B. So I can solve for x in this situation. I find x is greater than or equal to, I'm sorry, negative x is greater than or equal to -8. I now have to divide both sides by -1. And when I do that, I have to flip the sign and I get x is less than or equal to a +8. Okay, hopefully that is bringing back memories from our recent lesson. Now we're going to talk about things that we have learned in the past. Once the parent graph y is equal to square root of x is understood, functions in this form, f of x is equal to a square root of b times the quantity x minus h plus k, can be quickly graphed using the transformations previously learned in section 2.6. Recall, this is a very important concept, that changes before applying the function are horizontal. After applying the function are vertical. Okay, so let's take a look at what we have done. We'll start with A, which is before. And so therefore we have a vertical dilation. It will be a squish or a stretch and or an x-axis reflection. If A is negative, if it is a vertical, so let me just show you one thing. Remember we did the x squared, so if it's a vertical dilation is an x-axis reflection. I have reflected it across the x-axis, which is a vertical change, so to speak, okay? B is a horizontal dilation, so we'll take a look at B. B is under the parent rule, so it is before we have applied the parent function, which is the square root, and therefore it is a horizontal dilation. And if it was negative, it would be a y-axis reflection. So if I had a function that looked like that, I would, if it was negative, I would all of a sudden have a y-axis, and so the change is across. It is a y-axis reflection, but it is, you can see that it affects the graph horizontally, okay? All right, H. H shifts the graph right or left. So here is H. H is, again, before applying the function rule, which is the square root. And so we are going to shift to the right or left, which is horizontal. And then lastly, we have K. And K is outside the function rule, so it has to be vertical. So we're going to shift up or down. And so remember, this is our kind of parent function for square root, the parent function of square root of x, okay? So this again has to do with some previous lessons that we've learned, and we're going to redo them. So identify the transformations from the parent function and graph. So we have to use our words to identify the transformations from the parent function and then graph them. State the domain and range. Okay, I got to have my limits. What are my limits for my inputs, which are my domain, and what is my limit for my outputs, which is my range. Okay, so the first thing we see is that we have a negative. It is outside the parent rule. So it is in the vertical, it's a vertical translation, and that will create an x-axis reflection. And then I have this +1, and that is again inside the parent rule. So that is a horizontal. Well, we could just call it it's horizontal, right? And so what does that do? That shifts left. So that is left 1. Remember, if it's positive, it goes left. If it was negative, it goes right. And then we have this +3. It's outside. So that goes up 3. Let's just use the number. So one last thing that I forgot to show you is this 2. 2 is outside, so it is a vertical dilation. All right, so here was my special point to begin with, right? So that's what the parent function originally looked like. I would go over 1, up 1, over 4, up 2, and that is going to change. And so how is it going to change? So we will have to go left 1, up 3. So here's now where I start. And I have to have an x-axis reflection. So I'm going to start going downward. And so in addition to that, if I had 0, I would have had 0. If I had 1, instead of getting 1, I have to multiply it by 2. So I'm going to get 2. If I had 4, I would have gotten 2, but now I'm going to have 4 because I have a vertical dilation of 2. Okay, so over 1, down because of the x-axis reflection, down 2, over 4, and down, instead of 2, I'm going to go down 4. So here's my points. And this is what the new graph would look like. Let me make that a little cleaner. I can get rid of this red there we go. And now I have my graph. Okay. All right. Continuing on. We'll take a look and see, okay, I have a 2. This 2 is under the radical, so it's before the function rule. So we're going to go to the right. That's horizontal. We're going to go right 2. I have a positive 3. So I am going to go up 3. So remember the original parent function starts here, goes up 1, over 4, goes up to 2. All right, I have no reflections, but now I need to graph. I need to go to the right 2 and up 3. So there's my new starting point. And I have no vertical dilation. So up over 1, up 1, over 4, up 2. And now I can graph the graph. Okay. All right, continuing on. Oh, wait a minute. Hold up. We had to state the domain and range. So let's state the domain and range in both cases. I'll start with B. What is the domain? The domain, what are the inputs? Well, X has to be greater than or equal to 2. And then the range, those are my outputs, which is my Y, has to be greater than or equal to 3. And on this graph, we have the domain is X is greater than or equal to -1, and the range Y is, oops, not greater than, Y is less than or equal to 3. So this is a part of the answer, as is the graph. Okay, actually, as is the description of the transformations. All right, let's do another one, C. I have a negative sign, so I have a reflection. It is under the parent rule is horizontal, and so that is a y-axis reflection. I have +2, so I'm going to, oops, I'm going to go left, I'll just say left 2, and I have -3, I'm going to go down 3. Yeah, all right. All right, so where's my original graph? My original graph is here, and now that original starting point has to go left 2 and down 3. So I'll make that in green. So left 2, 1, 2, down 3. So here's where I start. Notice I have a y-axis reflection. So instead of it going this way, it will then start to go that way. So we are going to go to the left. And I do not have a vertical dilation, so I'm going to go over 1, up 1, over 4, up 2. 1, 2, there we go. Yep, and this is what my graph would look like. Now I have to state my domain and range. What is my domain? Those are my X values. X is less than or equal to -2. And my range, which is my Y, is greater than or equal to -3. Okay. All right, why don't you try one yourself? Welcome back. So I have an outside, I have 3, it's outside. This is a vertical dilation of 3. I'm going to, 4 is underneath, so I'm going to go left 4. We are going to go down 1. Okay, so originally, no reflection. So originally that graph is going to look something like this, right? And now I have to move that special starting point, left 4 and down 1. Okay, there's where I start. Now, vertical dilation of 3. So if you are struggling with that, we remember we have 0, 0. What is my original parent function? It was a square root of x, except this time I'm going to multiply the output as by 3. Instead of getting 1, I get 3. Instead of having the square root of 4 equal 2, I got to have 6. So I go over 1, up 3. 1, 2, 3. I go over 4, and then I go up 6. There's my dot, and that's good enough. I can get rid of the other one. And now we will figure out our domain and range. So my domain is x has to be greater than or equal to -4. And my range, y, has to be greater than or equal to -1. Okay, hopefully that's starting to make sense and bringing back memories, hopefully good memories. All right, there we go. We now have given the graph and we have to come up with, identify the parent. We have to determine the transformations from the parent function. Okay, parent function is square root of x, and we have to write an equation. So originally this graph looked something like this, and you can see that we have x-axis reflection, right? And so we need to take into account we have an x-axis reflection, which will be outside of the parent function. Okay, so that's the first thing. We noticed that instead of starting here, I went over right. So I went right 1 and I went up 2. Okay, so those are the 3 things I noticed. And then one last thing we should check is normally we would go over 1, either up 1, but this time we're going to go down 1 because of reflection. And sure enough, we did go down 1, over 4, and I'm sorry, that's not 4. This is 4. I went down 2. So it does not look like I have a dilation. Okay. All right, so now we got to come up with our function. So y equals, I have an x-axis reflection, which is a vertical translation. So I have square negative. I have square root of x. I went to the right 1, so I got to subtract 1. I went up 2, so I got to add 2. So x-axis reflection is here. Right 1 is here. Up 2 is here. Oops. It's not what I wanted. This is my answer. Okay. All right. Let's try another one. Let's look and see. I got this one. This is what it would normally have looked like. All right. So it does not look like I have a reflection, but it looks like I went to the left 1, right? I went to the left 1 and I went down 4. So I have left 1, down 4. Now we got to take a look at our, if we have a dilation or not. So I went over 1. I did not go over 1. Okay. In fact, I can go over 4. 1, 2, 3, 4. I went up 1 and I expected to go up 2. So the output was decreased by a half. So I know that I have a vertical dilation of 1/2. And so the equation will be y equals the square root of x plus 1 minus 4. And we have to have this vertical dilation of a half. Now, if you are struggling with finding that dilation, you can write your equation in this form. Whoops, excuse me. Square root of x plus 1 minus 4, and then go find 2 points on the graph for y and x. So you could find a point on the graph, for example, let's say right here, and that point would be 3 comma -3. Plug those values into that equation and solve for a, okay? But hopefully you don't have to do that, because you'll want to, personally, I would create a table of x and y values. 0, you started at 0. I had to go all the way over to 1, 2, 3, 4 to get an output of 1, and then compare it to what you were expecting, and what did I have to multiply what you were expecting by to get the 1. I don't know if that makes sense or not, but that's how I do it mentally. Let's left 1, this is left 1, down 4, that's down 4, vertical dilation of a half, there's my half. All right, why don't you try one yourself? All right, welcome back. We see that we have shifted over to the right. We have to the right 2. We have gone down 1, and now we need to check for dilation. I went over 1. Instead of going 1, I went up 2. So I went up 2. When I went up over 4, I expect to go up 2. And I didn't. I went up 4. So I multiplied my output by 2. So I have a vertical dilation of 2. And so what does that equation look like now? I have 2 square root of x minus 2 and minus 1. And so right 2, -2, down 1, -1, vertical dilation of 2, 2. And I have no reflections. Okay. Oh, I do have a reflection. Look what I have just not paid attention to. Okay, so originally that graph should have looked something like this. And I have a y-axis reflection, which is considered a horizontal translation. So I need to put that on there. That is a y-axis reflection. And so that will be in under the parent rule. Yes, okay. And what color have I not used? This one. And there's my negative. Okay. All right. One more set of problems to do. Which of the following is the graph of y is greater than 2x plus 4? We need to rewrite that. It's not in standard form. We need to pull out a 2, so x plus 2. And so first off, we see that we have a positive 2, which should be left 2. And we can see right away that b was to the right 2. C was to the right 2. And the only 2 options now are A and D, because they have gone to the left 2. Now, what else do we see? We see that let's just look at the greater than sign. Okay, so I have y is greater than. This is below, so I need all my shading to be above the function, and so that is why D is the correct answer, because it is above, because y is greater than. Okay, that's what we want. We want the y value. So now we have to give a reason. We want this greater than symbol indicates shading is above the curve. And the square root function was shifted left too. Okay. All right. Hope that lesson makes sense. Reach out to me if you have any questions.